So first, how do we investigate this experiment? Even knowing that this is a spiral spring. This is just the length of this spring when there is no mass attached to it. Applying a force or a weight of 50 grams. Now, we are going to pull this spring gently down and set it on a vertical oscillation. Now, the table of observation says making 10 complete oscillation. Making 10 complete oscillation. If you look at my table, I have T1 and T2. The essence of this repeated reading is to avoid random errors. And this average helps to limit the random errors that we produce during the experiment. So first, one of the precautions of this experiment is that you have to avoid drought. You also have to avoid conical oscillation. So first, I'm going to, this is a 50 gram mass. I'm going to pull them downward gently for 10 complete oscillation. Okay. So I'll start my time. Look at this. That's what we call conical oscillation. So I'm going to pull it downward again gently. Okay. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. I'm going to repeat the experiment again. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Pause. We may use some 20 oscillation. We are using 20 oscillation for this experiment. So setting a mass of 50 grams using the mass angle. Put this gently downward and I release. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So this gives us 9.3. This gives me 9.30 seconds. I'm going to repeat the experiment again to avoid random error. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, this one gave me 9.40 seconds. So now I'm looking at this. This is the average of these two times. So that should have joined 9.30 plus 9.40 together and find the average. Okay, let me see if I can achieve this. Okay, so this gives me 9.30 plus 9.40 divided by 2. So this gives me 9.35. Now this is the period of this oscillation. The period of this oscillation depends on the mass and the time of the oscillation. Mathematically, or the theoretical background of this experiment shows that this period of oscillation T, now we have 2 pi the square root of the mass all over the spring constant. So now this period of oscillation depends on the mass that causes the deformation of the spring. So the spring constant. So taking the square root of both sides, we are going to have T squared equal to 4 pi squared, the mass all over the spring constant. Now from the equation of a straight line in mathematics, if we have the y equal to sx plus c, now where y is an independent variable and it is a dependent variable and x is an independent variable. S is the slope. Based on comparison, this to this and this to this. So we are going to have that the slope S will equal to 4 pi squared all over the spring constant. So making the spring constant the subject of the formula, we have that K equal to 4 pi squared all over the slope. So from your graph, if you plot a graph of T squared against M on the horizontal axis, plotting a graph of T squared on the vertical axis against the mass M on the horizontal axis. You are going to have a straight line graph. You are going to have a straight line graph. So the slope gotten from this graph inset into this equation will give us the spring constant of this spring. Okay, let's move back to this evaluation. Now the period simply means the ratio of time to the number of complete oscillation. So if we have 9.35, so this will give us 9.35 divided by the number of oscillation, which is 20. So this will give me, now experimentally in physics we have three